I want to start my presentation with citing our CEO, Jetson, who always says that NVIDIA is not a GPU company, it's actually a platform company. And by saying that, he means that, we are all known as a hardware company, right? And often when I meet new people, they ask me, where do you work? I say at NVIDIA, and the first reaction I hear, oh, this gaming company, or in the best case, oh, this GPU company. But the truth is we're not only GPU or not only gaming company. We develop and provide the whole platforms, including hardware, including software as well. So it's really crucial to see NVIDIA as whole, as a provider of platforms, not only hardware. And yeah, I should move probably this one. Yeah. When talking about hardware and GPU computing platforms, it's of course important to mention the multitude of hardware solutions we have. And I'll focus the rest of my talk showing you such solutions as the latest Ampere GPU architecture, DJX systems for training, but also our embedded devices, the Jetson family. And it's also important to mention that our portfolio is not limited to these products only. So we have the whole range of computer graphics products, which are also capable of AI. So gamers here in the audience might have heard about our DLSS, for example, the technique which brought our rendering efficiency to the very new level. We also have the whole multitude of industry vertical specific solutions and products. These are hardware and software products included, which also have AI capabilities. So those of you who are familiar with autonomous driving, you may have heard about, for example, our Drive platform for autonomous driving. Those who work in healthcare may have heard about Clara platform for healthcare, including also our Clara AJX device, but also the software stack, Clara SDK. And we also have Isaac for robotics, which includes also simulation, synthetic data generation with Omniverse, reinforcement learning. These are just to name you a few. And this is my training part of the presentation. And here is yet another slide which says end-to-end platform. And the reason why there are so many end-to-end slides is that when talking about complete end-to-end, we really mean that. Our portfolio includes not only powerful accelerators, but also the whole networking stack of products. We also have software, including operational systems, accelerated libraries. So you all probably may have heard about CUDA, our legacy, but it's also a collection of high-level software and deep learning models. We have our own collection of pre-trained models, which you can use and integrate in your applications. And I'll also briefly mention this in the following slides. And with all it, we have the full capability to build scalable AI data centers. When I was invited to speak at this meetup, I was actually not sure what exactly shall I choose to present. So, you know, I'm a software person and my day-to-day focus is software. So I was thinking, shall I present the whole GPU product line, including like A30, A40, A60 GPUs? But would it make sense to go that deep into fine details? So in the end, I thought it's more important to provide you with the general feeling about our products and their features. And when talking about training, I decided to focus on the latest GPU architecture and features associated with it. And so I picked the top of the line GPU, which is A100 GPU, as a reference. I'm not sure if the window is blocking. Maybe I'll just put it like that. Yes. I guess I'm not hiding any slides. So in this slide, you see our flagman GPU. A180 gigabyte, and it uses the state-of-the-art HBM2E high bandwidth memory technology that we have efficiently integrated to make the world's first processor to exceed 2 terabytes per second of DRAM bandwidth, the world's highest memory bandwidth to feed the world's fastest GPU. And it builds on top of NVIDIA Ampere architecture, as I already mentioned, that has third generation of Tensor Course and a feature called MIC. And I will cover these features in the following slides. And finally, it also has the third generation of the NVLink technology, which provides 600 gigabytes per second of interconnect bandwidth between the different GPUs. This feature is also, NVLink are very important if you, for example, want to train large models like speech processing models, text, or recommender systems. And usually you don't train them on single GPUs. You need to interconnect multiple GPUs. And providing this high network capability, it really helps to make it in the most efficient way. So let's take a closer look at the mentioned features. The first feature I want to talk about is Tensor Course. So let's see what it is. A tensor is a mathematical object that describes the relationship between other mathematical objects that are linked together. So they are commonly shown as an array of numbers of different dimensions, and the dimensions of the array can be viewed as shown on the left. So NVIDIA's Tensor Course were designed to carry 64 general matrix multiplications per clock cycle on 4x4 matrices, which contains floating point 16 values or floating point 16 multiplication with floating point 32 addition. And such tensors are very small in size, so when handling actual data sets, the course would crunch through little blocks of larger matrices, building up the final answer. And this Tensor Course, why they're important in deep learning, they have a superior deep learning performance over regular CUDA course. As you may know, deep learning is largely about matrix operations. So firstly, we introduced this Tensor Course at our Volta architectures, but then we improved them in further Turing and Ampere architectures. And Ampere architecture, as on the A100 GPU, it supports acceleration for all data types, including floating point 64, the newly introduced TensorFlow 32, floating point 16, integer 8, integer 4, and binary int1. Also, in addition to that, new sparsity support in A100 Tensor Course can exploit fine-grained structured sparsity in deep learning networks to double the throughput of tensor core operations. I will introduce sparsity in one of the following slides. And the next feature of the latest GPU architectures, and similar to Tensor Course, it was also introduced in our Volta architecture. And in fact, this feature is also associated with Tensor Course, and it's called automatic mix precision. And often talking to my customers, I ask them when I talk to them about deep learning, do you use automatic mix precision? And I'm always getting very surprised when they say, no, we don't use it because, well, first of all, it's available already for 3 generations and it's extremely easy to use. So it's just, it just requires maybe adding like 2 to 3 lines of code into your TensorFlow or PyTorch application. It's also available in our Tau Toolkit, which I'll mention. And the idea behind is that, well, you run your training in floating point 16. The data enters your training in floating point 32, but then all matrix operations, all convolutions, they are computed in floating point 16. Before computing the loss, you switch back to floating point 32 to basically to preserve the accuracy as high as possible. And then like the optimization is also done in floating point 32. Once it's accomplished, the whole back propagation is also done in floating point 16. By doing that, well, you assure that the training gets faster, and well, it also reduces the memory bandwidth, as floating point 16 is more lightweight compared to floating point 32. This leads to, well, you can try different hyperparameters more often. You can experiment more often, but you can also try train with larger batches, or you can expand your architecture. You can train bigger models on a single GPU. So it's a very powerful technique, and I highly recommend you to use it if you have like one of the latest NVIDIA GPUs, because it doesn't cost you anything. Just a couple of lines of code will give you extra performance boost. And the next feature of this feature is new to our Ampere architecture, is sparsity. It's one of the optimization techniques designed to make a network to run faster, as well as similar to automatic mixed precisions, and also take less space. And the idea behind is that if there are zeros in the network, then you don't need to store or operate on them. On the A100 GPU, the structure manifests as a 2 to 4 pattern, which means that out of every 4 elements, at least 2 must be zeros. This reduces the data footprint and bandwidth of one matrix multiply operand by 2 times, and doubles throughput by skipping the computation of 0 values using the new NVIDIA sparse Tensor Course. And well, figure on the left just demonstrates how NVIDIA sparse Tensor Course operate on only half of one input to double the mathematical efficiency. The next interesting feature of the Ampere GPU is MIG, multi-GPU instance. Multi-instance GPU feature. It allows the A100 GPU to be divided or partitioned into up to 7 separate instances. By doing that, you can provide multiple users with separate GPU resources to accelerate their applications. And with this MIG feature, each instance's processors have separate and isolated paths through the entire memory system. This ensures that an individual user's workload can run with a predictable throughput and latency, even if other tasks are thrashing their own caches or saturating the DRAM interfaces. This MIG feature increases GPU utilization, the hardware utilization, while providing isolation between different clients. And this can be separate virtual machines, containers, and processes. This is especially beneficial for example, for cloud providers who have multi-tenant use cases. And it also ensures that one client cannot impact the work of scheduling of other clients, in addition to providing enhanced security and allowing GPU utilization guaranteed for customers. Typically, you can buy our training GPUs separately as parts of ready servers certified by our partners. But NVIDIA, we also offer a ready-to-use product called DJX. And DJX is a line of servers and workstations built by NVIDIA, which can run large demanding machine learning and deep learning workloads on GPUs. Presented on this slide, there is a DJX A100. It's the 3rd generation of DJX server, which includes 8 A100 GPU accelerators. It also includes 15 terabytes of PCIe Generation 4 NVMe storage, 2 64-core AMD CPUs, and 1 terabyte of RAM. And of course, our Mellanox-powered HDR InfiniBand interconnect. Mellanox was a company acquired by NVIDIA, so it was the missing puzzle in our server solution. And beyond the powerful hardware they provide, DGX systems come out of the box with an optimized operating system and a complete pre-integrated environment for running deep learning projects. They provide a containerized software architecture that lets data scientists easily deploy the deep learning solutions at scale. And we also provide management tools with minimal setup or configuration. And now I'm coming to the deployment platforms by NVIDIA. And well, it's important to say that for deployment, we cover also the whole range, starting from embedded devices to on-prem devices, and of course to cloud devices. So most of the cloud providers are also running with our GPUs, and you can deploy in A100 GPUs using the MIG feature or not using the MIG feature, up to your, well, it all depends on your use cases. And I want to focus the rest of my presentation on the embedded devices, which are Jetson family. And the Jetson family consists of, well, currently this device is presented on this slide. We have our credit card size Jetson Nano, which is a very low power device. It has like 5 to 10 watt. It is, well, it doesn't have that many Tensor Cores, so it's more considered like a toy for hobbyists who want just to get some feeling of how to deploy AI products on such tiny devices as Jetson. We have the TX2 series, which is, well, it's a little bit outdated, I would say. Like, also they are small and well, they are more powerful, of course, than Jetson Nano, and they can be considered for some lightweight industry tasks. And on top of the line, we have our Xavier series, Xavier NX, which is also tiny. And we have our AGX. The same device as Xavier AGX is used in our autonomous driving platform, Drive, for example. And recently, we have announced the new device is Jetson Orin. And as this bottom line devices, they still have Volta architecture GPUs. The Orin devices in the NX and AGX form factors will have the newest Ampere GPU. And they will be more powerful and, well, still can be used at the edge. And I want to spend another couple of words on integrated GPU, what it is and how is it different compared to the discrete GPU, those which you install in your workstations or the cloud providers have. And the main difference is that Jetsons have this, well, Jetson is a system on a chip model, which means that it comes always with an ARM-based CPU integrated, and it cannot be, well, stacked and used separately from the CPU. Well, this architecture provides you with the benefit of having physically unified memory. And let me explain you what is unified memory and how is it beneficial to use it. So I'll start with a little bit of a background. So how a typical discrete GPU setup looks like. So when programming CUDA applications, you may have noticed that we always need this step of, well, first data comes to the CPU. And in order to process it on a GPU, you need to physically move it from the CPU to the GPU, or in CUDA terms, we say it from the host to the device memory. So these operations are usually, well, they cause some kind of bottlenecks and slow down the computation because, well, GPU is super fast in computing, but this data movement sometimes is really undesirable. And the way it differs now in Jetson is that by using the SoC DRAM architecture, we can actually avoid this data movement between CPU and the integrated GPU, the GPU, how we call it in Jetson. You may have heard about the term unified memory also applied to CUDA programming. And the way it's different is that applied to CUDA programming, it's just a programming abstraction which is used to simplify the life of the programmer. So when you program it in the CUDA level, it works the same way. But on a discrete GPU, this process of the memory movement is hidden behind this abstraction, and on Jetson, it just doesn't happen. So by doing that, it means that we don't need any data copying, and we don't need any extra allocations, which you can imagine saves precious memory space and time. And another cool feature of a Jetson device, it's featured on NX and AJX devices, is that we actually add an additional deep learning accelerator to the chip. So in addition to the integrated GPU, we have the so-called DLA, NVIDIA DLA Accelerator, which allows you to offload some tasks from the GPU, but also you can use it for failover redundancy. Important to mention that some of the, it only works with some predefined layers, let's say convolutions and so on. But if you have developed your own some exotic layer, it won't work on DLA. So it works only with fixed operations. And on Jetson, you can access it through our TensorT API. Another thing to add, it's open source, and I provided you with a link. The hardware architecture is open source. So if you're a hardware designer, maybe it will be interesting for you. And I know I think I'm running out of time, so I'll be super quick here. And it's important to mention that also for Jetson, we provide our own software. And Jetson comes with our Jetpack SDK, Jetpack OS, which is basically Ubuntu-based operational system augmented with all the features required for Jetson. And you can train the models using our Tower Toolkit. You can download the models on our NGC website, and then you can easily deploy them on Jetson directly, optimizing them with our TensorT optimizing compiler and using further SDKs as DeepStream or Isaac for robotics. And DeepStream is for video analytics. So quickly going through the software products, and this is the NVIDIA GPU Cloud NGC website and how it looks like. And here we provide all our NVIDIA GPU accelerated, our software, which is optimized to run on NVIDIA GPUs. And here you can see we also have our TensorFlow container, our PyTorch container. The benefit of using those is that they are optimized to run on our GPUs. And we also have our Tower Toolkit here, which is our framework for training. Here is how the Tower Toolkit stack looks like. So we have models for vision AI, we have models for conversational AI. It currently runs as a set of Jupyter notebooks, which you can download from the NGC website, which I just showed you. And you can basically go following all the instructions in these Jupyter notebooks, and you can use the features of data augmentation. You can, of course, train the model with it, and you can use further optimization techniques like pruning and quantization-aware training. It all runs on top of our CUDA-X, so it supports NVIDIA Container Runtime, CUDA, cuDNN, and the models trained with Tower Toolkit, they are fully compatible with TensorRT. For hardware platforms, for training, you can use any workstation with NVIDIA GPU, DJX workstation, and the cloud. And as I mentioned, you can deploy on whatever NVIDIA GPUs you have, including Jetson. The models currently available are segmentation models, detection models, and classification models. We provide the most state-of-the-art backbones, and most popular frameworks are supported. And well, a couple of words also, I want to dedicate a couple of words to Tensor SDK, which is our optimizing compiler and the runtime. And it is very efficient. Well, it makes your inference very efficient on the given hardware. It performs some layer-intensive fusion operations, which means that you have your network graph and you optimize it by performing graph optimization techniques. We have quantization, basically, which is weight and activation, precision calibration. We provide kernel auto-tuning, which means that it kind of brute forces your own model in different hardware. And based on the performance on the given hardware, you get the best performing model on the dedicated hardware. It has dynamic tensor memory and multi-stream execution. So the workflow looks as follows. So you optimize your trained model on the target device. It is extremely important to take your model and optimize it on your target hardware because it is hardware associated. And then using the runtime, you can deserialize your model. The next software which I want to mention is Trident Inference Server, and I know that I don't have much time, so I just want you to maybe notice this slide, and also you see that it has many good features, and maybe you check it later. And the DeepStream SDK is also our framework for video processing, which also makes it super efficient. And the demo I prepared, it actually relies on DeepStream. It will be running on Jetson, and these are like typical examples of the demo, but I think I'll better show you my own demo. And I uploaded my demo on the GitHub. Here is the link, and go and check it out. And in order to show you the demo, I will switch to my Jetson device. And for that, I'll stop sharing my screen here. And I'll share my screen on the Jetson device. Okay, you can see my Jetson screen.
Yes, we can see it.
Yes, and I will start with a demo for emotion recognition. So this is basically like how my screen on Jetson looks like. You see that it's like a typical Ubuntu setup, and you can attach a display to it, and it runs like a normal workstation. But for that, it's tiny. So it will start my USB camera, and you should be able to see my face there. And you see that it's running real time, and it does my face detection. It detects the landmarks, the facial landmarks, including eyes, mouth, and nose. And if I try to make different facial expressions, I'm not a good actress, but I'll try. So this will be a happy face. Let me try and to do, surprise face. And then this one. So you see, it kind of works. And also, I'm streaming this through my Jetson. It works in the real time, but there are 4 different networks running in this application. So face detection, landmark detection, eye detection, and then the classifier. So you can imagine how efficient this device is. The second demo I prepared for you is a body pose recognition. And for that, I will have to stand up. And you see it starts recognizing body parts and body landmarks. And if I move, it is also very robust. And I have a mirror behind me, and you can see that it also detects me even if I'm occluded in some parts of my body there. So it also runs real time, as you see. It's not pre-recorded.
Very cool.
And then you can see it says like 9 frames per second, and it was also 9 frames per second, but I guess, yeah.
I don't know if you heard, but you got an applause there from here.
So this is it.
Yes, okay. Thank you very much for your presentation and also for your demo. I think it was very fun here to see it real life. Before I have a few questions, I also want to say that Akush is going to be having his presentation next, and also he's going to have a demo with at least one NVIDIA device, so you can also see it actually in physical here as well. And we don't have too much time, but do you have any questions from the expo sal? Yes?
Does she have any numbers how much faster it is to use hardware compared to?
It's not audible, so yeah, please.
Yeah, I will repeat now. You hear me, right? Okay, do you one more time? I can bring the mic to you.
I just wonder, do you have any numbers how much faster it is to run hardware compared to software on some examples?
Just to make sure if I understood the question right, do we have benchmarks how different software works in different hardware?
I just wonder, you can run everything on software, right? Or you can run using NVIDIA hardware. So I wonder.
Oh, this was running NVIDIA hardware, of course. So we like the software we develop, it works together with the hardware.
I just wonder, is it 10 times faster, 100 times like a graphical card? You know, you could do everything in software, but you have a graphical card to speed up a lot, maybe 1,000, 2,000. I just wonder if you have some numbers.
Yeah, you can find the numbers online. We have benchmark websites. I don't have a link right now, but yeah, if I know where to share, I would.
But I guess it goes quite much faster than just running on your own computer, right?
I mean, you cannot run everything on your own computer because, well, deep learning requires like many matrix application operations, and if using our software, it has to work with NVIDIA hardware. But of course, you can do matrix operations also on CPUs, but you will need different software for that.
We have one more question coming from.
Yes, thank you very much for a great presentation. So one thing that emerged from this particular presentation is the growing variety of both hardware and application and sectors that are considered by NVIDIA. And there are already hints that CUDA as a language is starting to struggle to represent the reality of the applications. For example, you talked about the integrated memory where the CUDA typical, let's say, idiom or syntax would expect to see this data transfer, and now it's no longer required. So this begs the question as to whether, as NVIDIA moves forward and, let's say, develops even further and more exotic hardware and software, will CUDA become a limiting factor in being able to express and represent accurately this new reality of NVIDIA options and products?
Well, it's actually, I would say that CUDA develops at the same pace as our hardware does. And I didn't mention, but at NVIDIA, we have more software engineers than hardware engineers. So always when announcing a new hardware, we make sure that we provide full CUDA support. So that's why also we have our internal CUDA developers conferences where they sometimes announce new hardware features. And this is usually very exciting to attend those, because from the software developers, we actually learn about the new future hardware products. So it's all, I think it all goes hands in hands together. And there is a nice symbiosis of two products, of CUDA and, various hardware.
Okay, thank you for the questions and answer, and thank you very much for your presentation and for this crash course into NVIDIA devices. It would be nice, of course, if you could be here and mingle with us, but I guess people will reach out for you to LinkedIn if they have want to connect. And,
yes, please.
Yeah,
feel free.
Thank you so much.
Thank you. Thank you for having me, and have a good day. Bye-bye.